Hi friends, let's understand what a number line is.
So basically, we all know the ruler or a scale, which is a part of our geometry box, right? So it has markings for 1 centimeter, 2 centimeter, 3 centimeter, etc. etc. Now, the number line can be thought of as just an imaginary infinite scale or ruler because even it has markings and it has numbers. On the right hand side, we have numbers like 1, 2, 3, etc. increasing towards the right, which are natural numbers and which are positive numbers, right? We have 0 in the middle, and we have the negative numbers which are decreasing towards the left. So -1, -2, -3, -4, and decreases, so on and so forth. Also, there are other types of numbers also on the number line. For example, if we look at the position exactly halfway between 1 and 2, we get 1.5, right? That can be expressed as a fraction as 3 by 2. Similarly, on the negative side of things, if we look at the 3/4 way between -2 and -3, 3/4 way, we get -2.75, which can be expressed as -11 by 4, right? So there are a lot of decimal numbers and fractions and all other kind of numbers on the number line. Okay, so the fractions are decimal numbers. Also, the fractions are called as rational numbers, and the rational numbers are numbers of the form p by q, where q is not equal to 0. For example, if you take the number 2 by 3, which is a fraction, which is also a rational number, p is equal to 2, which is the numerator, and the q is equal to 3, which is the denominator. Okay, so if you look at the number line and if you consider a set of only positive natural numbers 1, 2, 10, etc., they form a small set. Okay, now if you add 0 to this and make it a bigger set, right, these numbers are called whole numbers. Okay, so they're a bigger set including 0 and the natural numbers. Now even bigger set includes the negative numbers also. So 0, 1, 2, 10, that is positive, and -1, 2, -3, -12. So these are together known as integers. Okay, and if you include the fractions also in an even bigger set, this set is what are known as rational numbers. So the rational numbers have fractions such as 2 by 3, 3 by 5, -6 by 5. They have negative numbers such as -1, -2. They have 0, and they have 1, 2, which are positive numbers. Okay, even bigger set is numbers which are irrational. So why are these numbers called irrational? They are called irrational because their decimal places keeps on continuing without end. For example, square root of 2, it will be calculated as 1.4142, etc., and it keeps on going. The value of pi, 3.14159, and it keeps on going. So any number whose decimal places are non-ending are called irrational numbers. So there are such numbers also on the number line. So friends, number line is nothing but an imaginary scale, imaginary ruler on which you have 0, you have the positive numbers, negative numbers, you have the fractions, you have the rational numbers, and you have the irrational numbers. Hi friends, there are some points which we can think about and ponder about. So if we ask ourselves, is every whole number a natural number? The answer is no, because see, 0 is a whole number, but it is not a natural number, right? It belongs to the bigger set, not the smaller set. And if we say, is every integer a rational number? Yeah, because see, if you take any integer, let's say 1, 2, 10, or -2, -3, every integer I can be expressed as I divided by 1, right? Because I divided by 1 is I, which is in the form of p by q. And is every rational number an integer? The answer is no, because if you take a rational number 2 by 3, certainly it's not an integer, right? So let's say we give you two numbers, let's say 1 and 2, and we want to find 5 rational numbers between these two numbers. How can we do it? So the step one is, since we need 5 rational numbers, just calculate the number of rational numbers plus 1, that is 6 in this case. Then what you do is multiply and divide each of the above numbers by that number. So since we have the number 6, 1 can be expressed as 1 by 1, which is equal to 1 into 6 divided by 1 into 6, that is 6 by 6, right? 6 by 6 is 1. And 2 can be expressed as 2 by 1, which is 2 into 6 divided by 1 into 6, which is 12 by 6. Okay, so once the denominators are same, that is 6 and 6 are the denominators, and we need to find the 5 numbers, and that can be found by increasing the numerator. So the 5 rational numbers are 7 by 6, 8 by 6, 9 by 6, 10 by 6, and 11 by 6. Okay, so if you look at it on the number line, you can see the image where there is 0, there is 6 by 6 for 1, 12 by 6 for 2, and you can see the blue markings of 5 rational number positions, which is 7 by 6, 8 by 6, 9 by 6, 10 by 6, and 11 by 6. Okay, so if you zoom into the number line, you can find many more rational numbers, and in fact there are infinite number of rational numbers between any two numbers. Hi friends, let's understand how to construct square root of numbers on the number line. So to mark square root of 2 and square root of 3 on number line, we start off with drawing a straight line and marking various points 1 centimeter apart. So we can start with 0, then 1, then 2, then 3, 4 and 5. Now what we do is we construct, using a protractor, we construct a perpendicular line at 3 to the line that we have already drawn. And the angle between these two lines is 90 degrees. The next step is we mark 1 centimeter from point 3 on the perpendicular line, and the new point will create a segment whose length is 1. We join these 2 points, the point number 2 and the new point, and we call this new segment x, and its length is x basically, right? So Pythagoras theorem tells us that if we have a right angle triangle, the hypotenuse squared is adjacent squared plus opposite side squared, the lengths. So for our case, we get x squared is equal to 1 squared plus 1 squared, that is x is root 2. Now to compute root 3, the length of root 3 on the number line, we do a similar process. We just create a perpendicular line to the line segment whose length is x. Then we again mark off 1 centimeter on the perpendicular line. And we indicate the segment from the point to this point as 1 unit, and we join point 2 and the new point using a line segment, and lets its length be y. Okay, so again applying Pythagoras theorem, we see that y squared, which is hypotenuse in our case, is x squared, which is adjacent side squared, plus 1 squared. But we already know that x is root 2, so x squared will nothing be root 2 whole squared, that is root 2 into root 2, which is nothing but 2, plus 1, that is 3, so y will be equal to root 3. Okay, now that we have got the lengths of root 2, which is x, and root 3, which is y, what we do is we use our compass and draw a arc of radius x starting with 2 as the center, and we cut it to the initial line we had drawn. Okay, similarly we draw another arc of radius y. Hi friends, let's look at how to calculate the decimal values of rational numbers. Let's look at how to convert fractions into decimals. So let's take 10 by 3. So if we do simple division, right, it goes by 3, 3 3s are 9. Once we put a decimal point, we get to put a 0 again. You have 3 3s are 9, and it keeps on repeating. So 10 by 3 is 3.333, etc. It's repeating there. Okay, so this is a case where the numbers after the decimal point are the same and they keep repeating. Let's consider 7 by 8. So if I divide 7 by 8, it's smaller, so I'll put 0 point and I'll get 70. Then 8 8s are 64, then 6 0 is a remainder, 7s are 8 7s are 56, right? Then 4 is the remainder with 0, and 8 5s are 40, right? So it stops there. So here 7 by 8 is equal to 0.875, and there are decimal numbers do not repeat here. Okay, so this is one case where you can see that this fraction's decimal value does not have any continuously repeating digits. What about 1 by 7? So if I divide 1 by 7, I'll put a point, I'll get 7 1s are 7, 3 is the remainder, 3 0, 4s are 28, 2 is the remainder, again 2s are 14, right? 6 is the remainder, then 7 8s are 56, right? 4 is the remainder, 40, then 7 5s are 35, and 5 is the remainder, right? 5 0, 7 7s are 49. Now see what happens. 1 0 comes back again. Okay, so this 10 1 0 is repeating here. Okay, so if we proceed again, you will get 1 4 2 8 5 7, like that it will keep repeating. So to denote that it is repeating, we can write it as 0.142857, and we can put a bar on top of 142857. Similarly 10.33 on after the decimal point, we can put a bar. Hi friends, now let us see how to do the reverse, converting a decimal number to a rational number. Hi, so let's look at converting decimals to fractions. So if I have a number 3.142678, how would I convert it into fraction? This is the easy case because there are no recurring digits. We just need to take away the decimal point and divide by the appropriate one with appropriate number of zeros. Here there are 6 digits after decimal point, so we just divide it by 1 million. So that will give us the fractional representation of the decimal number. But what if it is 0.333 recurring? How do we convert this into fraction? So basically we use a math trick. We assume that x is equal to 0.333 recurring, then we do 10x, which is 3.333 recurring. Okay. Now if we see write it as 3 plus 0.333 recurring, we see that 0.333 is nothing but x itself, right? So what we can write is 10x is equal to 3 plus x. Okay. When we bring the x to the other side of the equal to sign, it will change its sign, it will become minus x. Then we'll have 10x minus x is equal to 3. That is 9x is equal to 3. X is equal to 3 by 9 or 1 by 3. So this is the fractional representation of 0.333 recurring. So now if we have something a little more complicated, let's say 0.235, 235, 35, etc. Notice that 2 is not recurring, only 35 is recurring. 35, 35, 35. Okay, and notice that 2 digits are recurring, not only 1 digit, it is 3535. So if we say x is equal to 2.3535 recurring, where only 35 is recurring, we have to multiply it now by 100x because there are 2 digits which are recurring. So we'll get 23.53535, etc. But we want to do a trick wherein we want to use the x. So we have 5 in the decimal place, we want 2 there. So what we do is we break it up like 23.3 plus 0.23535 recurring. So what this enables us is to replace 0.235 by the x itself. So this will become 100x is equal to 23.3 plus x, that is 99x. 100x minus x is equal to 23.3, that is 99x is equal to 23.3, and x is equal to 23.3 divided by 99. Okay. Now to make it a p by q of a fraction, we can multiply the numerator and denominator by 10, giving us 233 by 990. Okay. So this is the fraction.